Awesome. Okay, thanks everyone for joining. My name is Ben Weinberg. I'm a developer advocate with the Axelar team, or with the Interop Labs team. Today we're going to be demoing an advanced use case for our new interchain token service product. I'm going to share my screen here. Here we go. Confirming, can you guys see? Can you guys see my slides? Yeah. Awesome. Okay, yeah, so like I said before, my name is Ben. I'm based out of Toronto, Canada. Shout out to all the Canadians tuning in. And let's get right to this, this demo. So like I said before, it's going to be on building an advanced ITS token integration. So before we move any further, what is ITS? Well, ITS stands for Interchain Token Service. It's a product which the Interop Lab team released a number of months ago now. And easiest way to put it is that it allows you to take two paths, really. If you have a new token which you want to deploy on multiple chains at once and have those tokens be interoperable, you can do that. And the other route is you can take an existing customized token which you already have and wire that up to ITS, to Interchain Token Service, and provide bridging functionality for those custom, potentially more advanced tokens. For the first case that I mentioned, in terms of deploying tokens via the Interchain Token Service itself, we actually have a pretty nice little front end for that. I'm going to pull that up right here. I'm not going to step through it, but I will share the link for the testnet version right here. So you guys can all play around with it if you want. It's a really, really neat service, but here is a little screenshot I have from this kind of no-code solution, which we want for anyone who wants to go right now actually and deploy new tokens on multiple chains and actually send transfers between the chains. You can see here, this is an example of how it looks like. I've deployed a token here on Ethereum Sepolia, registered it on Blast and on Avalanche. And you see I have the option to transfer this token between Blast and Avalanche. I have my token address. I have my token manager address. I will return to what a token manager is later in the presentation. But I can also register this token on several different chains, including Moonbase, Phantom, BNB, Kava, any chain which Axelar is connected to. So what are we actually going to be building today, though? Talked a lot about the ITS service, the front end, having deployments through ITS. But what we're going to be focusing on today is the latter use case that I mentioned before of actually wiring up custom tokens to ITS to provide bridging functionality for your pre-existing tokens. And we're kind of taking inspiration from real world use cases that we've seen and discussions that we've had with other teams. And that's kind of the inspiration for what we're doing here. So the kind of 50,000 foot view here of what we're going to be building before we step into the code. Apologize, I'm getting over something here. We're going to be starting off on the bottom left corner here with what's called our native token. That's going to be our quote unquote advanced token that we're building out. It's going to have some functionality, which I'll get into later. But the deployment of this native token on Celo, which will be our, our home chain, will be done through the token factory, which we will also be building. Okay, so token factory can deploy the native token. And I want to go back to what I mentioned before, that this design is coming from inspiration from real world use cases, which we've seen. Also, if anyone has any questions, just post here. I'll be checking the comments. But some of the real world use cases we've been seeing is situations where teams, for example, in the stablecoin space, might have certain regulatory restrictions which they have to follow. In other words, you might be regulated to operate on some chains, let's say Celo in this use case, where we can use our advanced native token as it's meant to be used. But on other chains, let's say Moonbeam, you might not really be regulated to fully operate there with your native token itself. but you still want to have some presence there. So what we've seen is the use case of these semi-native tokens, which are kind of light wrapped versions, or let's call it light versions of your tokens, with not all the features necessarily baked in the way it would be with the native token, but you can actually transfer these tokens between each other, so you still have some sort of presence on these other chains as well. So how's the flow going to be? Well, we're going to build our native token. This is our main token that we're working on. It's going to be deployed via the token factory. Now, on a chain where we might not be regulated to operate our native token there, let's say Moonbeam, we can use an instance of our token factory, let's say the deployer, where anyone can go and deploy what's called a semi-native token on that new chain. And as I said before, the semi-native token is going to be a token which is like a light version of our native token. So how's this going to work? Our token factory is going to send what's called a GMP message to the deployer. GMP stands for General Message Passing. It's the ability to send messages between chains. It could be as simple as a "Hello World" message, or as built together as a deploy this token and wire it up to ITS message, which is what we're going to be doing today. So we're going to use GMP to talk to our deployer, which is an instance of our token factory on a different chain, which will then deploy the semi-native token. And then via the interchain token service, we will be able to send cross-chain transactions from our semi-native tokens to our native tokens, on CeeLo to Moonbeam to any other chain which we want to deploy on. So let's get to it. We're going to start off with building the native token. Any questions so far before I get going? Sorry about the cough. It's as annoying to me as it is for you guys. Cool. If not, I will start building this out. So we have some stuff pre-built already. Otherwise, this would take us forever. But we have this native token. It's following being built with OpenZeppelin's modules. So you'll see it's an ERC20 upgradable. And let's start right here from the initialize function. Okay. This is, like I said, it's an upgradable token, so there's no constructors with upgradable tokens. So we're going to have to use this initialize function as if we were using a constructor. So the first thing we want to do is actually pass in some parameters into this initialize. We have a fifth contract here, which I didn't show on the slide before, called access controls. This will basically be handling like role management for our token. So like minter roles, admin roles. We even have blacklisted addresses, which we can track here on access controls. And we'll use this to oversee management of the token. So the first thing we want to do is pass in the address of our access control, here. We also want to pass in the address of ITS itself. Remember, ITS is what we're going to be using to connect these tokens kind of to the Axelar world and provide multi-chain functionality here. So we need to pass in the address of ITS itself. Next, we're going to pass in some unique parameters to our token. We're going to pass in the burn rate and the transaction fee rate. And let's set these up right here. I'm going to pop back to my PowerPoint momentarily for one last slide about this token. First, let me just wire these up quickly. ITS and access control and storage correspond to these two parameters. And let's create two new storage variables for our burn rate and our transaction fee rate. STX fee rate. And I will go back to the slide to explain exactly what these two variables are doing here. Burn rate and TX fee rate. Sweet. So the last slide I want to share is, remember, our native token is going to be like our custom token, which we're working on right now. The semi-native token is the more light version of that token. Can I zoom in a bit? Yes, I will zoom in as soon as I'm back to the code. What we're going to be doing on our custom token is we're going to have several features baked in. First, as I mentioned before, it's going to be an upgradable token. it's going to have transaction fee accrual. What does that mean? And a burn rate. The transaction fee and the burn rate might sound familiar. Let me zoom in a bit. We just actually passed these in to our initialize function, and they're going to be serving different use cases. They're both going to be fees which are kind of deducted from our tokens when we're actually transferring from address A to address B. I'm going to be paying a fee as the sender, and a portion of my tokens will be burnt as the sender. The fee will go towards what's called a community pool, and it's kind of like a pseudo, like, you can call it almost like a loyalty mechanism for people to hold your token. As holders of the token, the reward pool will grow from transfers, and then you as the holder can claim rewards from that token in proportion to how many tokens you're holding. And then the burn rate will be used to kind of combat inflation of the token, where like a small percentage will be burnt for every transfer that is sent. These are all real world use cases. We're going to be building out a simplified version of these use cases just for this demo. The transaction fee, burn, and the burn rate. The last thing I want to call out for this token, for the custom token, is that we're going to be using create3 to deploy this token. This is a kind of helper service which the Axler team has made available to actually make sure that the contract that you're deploying is at a specified address that you choose. It's kind of similar to how like you get an address via your nonce when you're deploying a token and the deploying address. With create3, instead of relying on a nonce, which you can't really determine, you can actually be passing an assault, which is you can actually control. And the reason we're doing this is to make sure that our tokens that we're going to be deploying on CeeLo, on Moonbeam, on Ethereum, on any of these chains will have the same address to improve overall user experience. So that's what create3 is for. And I think that is the end of our slides. So let's go back to the code here. I hope this is big enough. Someone can call me out if it's still too small. What we've done so far is called an initialize function and passed in these key parameters here, which we'll be using. So let me scroll down a bit to what we have. We have pausing and unpausing functionality. We'll come back to this momentarily. We also, let me remove this for now. We also have mint and burn functions. Okay, minting and burning. Naturally, there are very important functions for any tokens, but they're the only required functions for custom tokens that are being built and integrated into ITS. A custom token can really have whatever functionality and features you want. I'm trying to demo a bit of those now, but two functions that you have to have are mint and burn, because that is what ITS will actually be, or your token manager, I should say, will be interacting with or triggering on your token when it's bridging the token from one chain to the other. It's going to be more often than not burning it on one chain and minting it on the other chain. So you have to have these functions available for the service to interact with. So we have mint defined here and burn defined here. And if I scroll down, we have this update function. This is coming to us from OpenZeppelin for upgradable tokens. It's basically going to be triggered every time that we want to actually send tokens from one address to the other. In our case, we do want to have some custom logic that is being ran for every transfer. So we will build that into this update function. What is the custom logic that we want? Well, if we come back to our slide, wherever it is, it will probably have something to do with the burn rate that we want burnt on every transaction, and the transaction fee, which will also be deducted for every transaction. So let's, sorry about the cough. Let's build that into here. First, remember we set at the very top, we set our burn rate and our transaction fee rate. But let's actually get the burn amount that we want to be burned. So let's calculate that. It's going to be the value of the transfer that we're sending times the burn rate, which we have in storage, divided by 1 to the power of 18, because this token will have 18 decimal points. And it'll be very, very similar for the transaction fee. So instead of burn rate, we're going to go times transaction fee rate divided by 1 to the power of 18. Hope we're all good up till now. Check the questions. We're good. So now what we want to do, now that we actually have the burn amount and the fee amount, let's get how many tokens we're actually sending. And we do that very simply by checking the value, subtracted by the fee, subtracted by the burn amount. Now we have the actual amount that our receiver will be sending. So if the burn amount is greater than 0, which it will be, we will burn from, we'll be burning the burn amount. Now, if the amount, this is just to make sure that everything is adding up correctly. So if the amount sent plus the burn amount plus the fee is not equal to value, then we will revert with the custom error invalid send amount, which we defined up top. This is just some safe checks. Now that we've burnt our token with the burn amount value, we actually have to do something with the fee. No, we're not actually burning the fee. We want this fee to go towards a community pool, I'm calling it, that token holders can withdraw from. So we will increment the reward pool, which I have to define up top, plus whatever the fee is. Let's define this up top quickly. 6 public reward pool. Great. So at this point, for every transfer that we send, we will be burning a small portion, and we will be incrementing reward pool proportional to how many tokens we're sending. Then this should be down here. We will let OpenZeppelin do its thing and call the update function. And the last thing we can do, just for fun here, is to call a reward added event to say like, hey, a new reward has been added to the reward pool. We could use this for like indexing or something like that. Now there's one problem here, which is that this update function, as I said, will be running every time tokens are transferred. And for the sake of this demo, I don't want this every single transfer. I only want it when it's going from like party A to party B. In other words, not when we're minting a fresh new token. So there's an easy fix for that. If the from is address 0, I will still call this. We still need to call the update function, but we'll return immediately. We're not going to go through the rest of this burning and the transaction fee for if we're minting. And that is it for updating. We're almost done our custom token here. There's some more basic functionality we want to add. Note we set the burn rate and the transaction fee rate in our initializer, which is kind of like a constructor. It's only going to be run once. So what if we want to actually change those burn rates and transaction fees over the lifespan of this token? Well, we have this function called set burn rate, which will take in a new burn rate when not paused, and we will simply set the burn rate to this new burn rate. And let's do the same thing for the transaction fee rate, except we'll call it TX fee rate, new TX fee. This probably would have been just as easy to type it, whatever. Yeah, copying and pasting is not my strong side. New TX fee and underscore. Oh god. Okay. So at this point, we can now set a new transaction fee and a new burn rate. Thing is, we don't want just anyone to do this, so let's make use of our access control function, which we wrote up earlier, and we've imported here in the initialize. And we're going to call, actually we have to define a modifier first, which we'll be integrating with our access control. Let's call it something like isAdmin. And what we'll be doing here is making sure that whoever is calling this function is registered as an admin in our message sender, in our access control, sorry. If the message sender is not an admin, then we can revert and say, like, hey, only the admin can call this function. So let's throw this guy in for both the burn rate and the set transaction fee rate. We will leave the mint and burn as empty. In theory, we'd obviously want to take an abundance of precaution for who can call these functions. But I'm just going to leave it open for the purpose of this demo to make things a bit easier. We can also have the is blacklisted modifier as well that we made here, but for time's sake, I'm going to pass on this for now. I'll make sure to add it in the completed code. And I believe that is just about it for the token. Let me see, any questions? Nothing yet. There's just one more function or one more external function that we need to define. Remember, we have a reward pool, which I defined on line 30 here. The issue is there's no way to actually claim your rewards as a token holder. So let's bake that in very quickly here. Don't need any parameters, which I love. When not paused again. So we have to first, to claim the reward, we have to know how much of a reward each user is getting when they're claiming. So we will have another helper function here called calculate reward. And this will be unique to the sender or the person claiming the reward. So calculate reward takes in an address, which will be the message sender. View internal returns image56. Just make everyone happy here. And let's just call reward pool, remember, which we defined up top, times the balance of like how many tokens our message sender is holding, divided by the total supply of all tokens in existence. This is going to be the kind of simple way we're calculating the reward. Now that we have this reward here, we can deduct the reward amount from the reward pool. We can then mint new tokens for whoever is calling this reward or whoever is claiming this reward, and then we can emit another event which we can use when we are indexing this contract called reward claim. And that is it for our custom token. We now have a token which is following an upgradable pattern, has all the ERC20 functionality from OpenZeppelin baked in. We can pause it, we can unpause it. This should also be, I guess, only, or is admin. Set burn rate can only be done by is admin. We can mint, we can burn tokens. We have to make sure these are public or external. I think this has to be public, yeah, because we're calling it here. We can claim rewards, and we have all this burning and transaction fee handling done here in the native, in the update function here when the token is being transferred. Cool. Now, if we come back to our slides, we have now built this native token. Thing is, we have to deploy this native token both on Silo, our home chain, and we want to be able to deploy semi-native tokens or even native tokens on other chains which we might be regulated on. And that is all going to take place in this token factory. So let's build this guy out. I'm going to close native token and access control for now. I'm going to pop open the token factory. So you'll notice we have some to-do functions here, some functionality that's already built out. Again, I apologize. That is because it could be here for hours if you're building this out completely from scratch. So let's walk through what we already have, and then we can build out some of the remaining functionality together. We have a couple Axelar libraries being passed in here, which you'll see being used in a bit. A couple of custom errors, some storage variables. I'm going to start right with the initialize function the way we did last time. So again, we pass in the address of ITS, which we're going to need to be interacting with here on the token factory. We pass in the Axelar gas service and the Axelar gateway. I will come back to these two contracts later when we're actually doing the cross-chain functionality. We're building that out. We pass in our access controls again to handle rules for this factory. And then we pass in our deployer. This is going to be like our instance of this token factory on different chains, which this will need to interact with when we're making cross-chain calls. We pass all these guys into their respective storage variables, and we set a salt here for our ITS token. This just is a hex value for 1, 2, 3, 4, 5. And I'll come back to this salt and why it matters in a bit. We have this function, which we build out together. And then this is probably the biggest function that we have built out here already. So let's walk through this. This function is called deploy home native. What will this do? You can take a guess. It will, as the slide suggested, deploy our native token on our home chain. So we take in two parameters, the burn rate and the transaction fee rate, remember, which our native token will need to know what these two parameters are. They take these in the initialize function. Right here, we pass in these two guys. So this is where the root of where we'll pass them in. We want to make sure that our native token in storage here is at address 0. In other words, saying like, hey, have we already deployed a token here? If we have, then forget it. We don't want to deploy a duplicate. But if we have not, we can proceed. We have two more salts here. I apologize for the kind of ugly hex. I will come back to these as well in a bit. So this is our third salt. Now we can actually deploy the token. Remember, one of the big things we want here is to have an upgradable token. Now, I'm not going to go super in depth on how upgradables work, but the quick 10-second spiel is that you have an implementation contract and a proxy contract. The proxy contract will point to the implementation contract. Okay. The proxy contract for us is coming from OpenZeppelin. We're using a transparent upgradable proxy. And when we're upgrading, we can like substitute in new implementations. And that's how we get kind of the pseudo upgradability. So the first thing we have to do is deploy our implementation, which will be our creation code of our native token v1. What is native token v1? That is this guy, what we just spent the last 10 minutes building out. So we need the creation code here. And for create 3, which I'll come back to in a sec, we need a unique salt. And that is this 1, 2, 3, 4 salt that we have up here. Create 3, I mentioned in the slides, if you guys remember, is we're inheriting from it up here. It's basically a helper service coming from Axelar, very similar to Create 2. I think it's actually using the opcode under the hood. And it basically allows us to configure which address we want to deploy our contract at. So instead of relying on a nonce, we are passing in our own salt implementation. And now when I deploy this contract on a different chain, I can pass in the same salt, and we will have the same address on all these different chains. That's what Create 3 does for us. So in line 101, we use Create 3 to deploy our new implementation. Line 102, we make sure that it is no longer 0 address. If it is, something went wrong, and we can just revert. Next thing we want to do is actually deploy our proxy. Remember, the proxy points to the implementation. We have this helper function, which I defined earlier, called get encoded creation code native. I'll go into this very quickly. Basically, it encodes a lot of the data which we need to actually deploy our proxy. So that includes, let me close this. That includes the initialization data for the token itself. So like access control, IPS, burn rate, transaction fee rate. Remember what we had up here. It also, where are we? Encodes what we need for the proxy contract itself. Remember, the proxy is going to be different. That's the transparent upgradable proxy. So that takes what is the implementation address that I'm pointing to, who is my proxy admin, and what is the initialization data that we're going to actually be using, which is what we have on line 142. So we encode all this together to get our proxy creation code. And once we have our proxy creation code here on line 105, we can again call create 3 just like we did in line 101 here with our implementation. The difference is this time we're doing it for the proxy. So we pass in our creation code, and we pass in another unique salt from line 97, 1, 2, 3, to make sure that our proxy will have the same address, or that we can determine what our proxy address is going to be. We're going to be using the same salt on our destination chain when we're deploying our tokens there as well. Checking, again, ask questions if you want. We'll be moving on from here. Line 109 is the same thing as line 102. Make sure that the proxy is not address 0. If we did, we have an issue. And then set the address of that proxy in storage. Notice how we're not doing it for the implementation. That's because the proxy is what our users will actually be interacting with, not the implementation. We probably don't even need to have create 3 for this, but I did it anyway. So all this, let me comment this out for now. At this point, once we call deploy home native, we will have successfully deployed an upgradable version of this native token v1 contract. Hooray. But remember, what we want to do is not just deploy this token on one blockchain and interact with it. The whole point is our beautiful, wherever it is, interchain token service. We want to be integrating our token with ITS, with this interchain token service. So how do we do this? We have to actually speak to the ITS contract itself. Recall, we passed it in here in our initialize function, so we have an instance of it. And ITS has many, many different functions which we can call. The most relevant for us now is deploy token manager. This is how we actually deploy a token manager, which will be kind of what facilitates our communication with Axelar and with the ITS protocol. A quick word on token manager, because I'll be referring to that a lot. And if you've gone through our docs, you've probably seen it a lot. A token manager is a unique contract, which you can think of as kind of like your buddy for your ITS token, or your ITS connected token. There are two types, or there's more than two types, but the two main types we'll focus on now is mint burn and lock unlock. You see here on line 116, we went for the lock unlock approach. Mint burn, as the name suggests, will basically mean that when you're bridging your token via this type of token manager, it'll burn your token on the source chain, mint it on the destination chain. Lock unlock, as you might guess, it doesn't actually burn it on the source chain, it just locks it up. And then when we're bridging back, it unlocks the locked tokens. Since we kind of are having the whole home chain approach here, where like we have the semi-native tokens corresponding to the native tokens on CeeLo, I opted to go the lock unlock approach. But if you don't have a home chain, if you just have like a token on 8 different chains and it doesn't really matter like what the home chain is, then it's just easier to go mint burn. But for now, since we have the home chain, we're going to go lock unlock. So we call this deploy token manager. Deploy token manager, let me pull this up so you guys can actually see it side by side, sorry. It takes several functions here. You can see on the right-hand side here where it's defined. It takes a unique salt, which we'll be using for the token manager deployment. We use that to generate our what's called an interchain token ID, which is what ITS will use to track your token across X number of chains that it's connected to. That's why the salt is super important, to make sure that you have the same interchain token ID across all these different tokens. Next, we have the destination chain. Notice for us, it's empty. That's because we're deploying the token manager on the same chain as this contract. We're not sending a cross-chain call here. So we just leave it as an empty string. Next is the token manager type, which I already mentioned. We're doing lock unlock for us. Next is the params, which might be a bit unclear. What it basically means is we have to encode an address, which will be an operator. An operator is an address which can like have certain roles for your ITS integration. The main one being like setting what's called flow limits, which are like rate limits for how many tokens can be sent in and out of a chain. So who do I want to be the operator? I want it to be me. So I just set the message sender, and I'm using the 2 bytes helper here that we are using up top. And what is the token that we're actually deploying for? Well, that is just the new token proxy, which we recall deployed right before this. And lastly, we need to send a gas value to actually cover this transaction. I believe we could actually send 0 here, since deploy token manager, we're not actually doing a cross-chain call. If we were doing a cross-chain call to like Moonbeam here, we'd have to pay the fee. But since this is the same chain, we probably don't actually need it, but I'll leave it in there for now. And then we have our fun little event there, which will emit that we have deployed a new token with the address of the token and connected it to ITS, and that we have a token ID for this token, which is awesome. So at this point, when we call this function, we will deploy this native token, an upgradable version of that native token, and connect it to ITS, so it's bridgeable, all in one click. Let's actually code the next function here together. How are we for time? We'll probably be a bit over an hour, but this will be recorded if people want to watch later. So let's actually start writing this guy up. Deploy remote semi-native token. I'll close this for now. So the first thing we want to do is kind of similar to what we did here on line 95. We want to check, hey, is semi-native tokens the chain that we're about to deploy on? Because recall, this function is going to be a cross-chain transaction here. This function is not. So we are going to be tracking all of our tokens deployed on these kind of remote satellite chains via this mapping of semi-native tokens. So we want to make sure that there is currently no token already deployed there. We want to make sure its address 0. We also want to make sure that we have a native token deployed on our home chain. If any of these conditions are not true, then we want to revert, because we have to make sure that we don't have a native token already, a semi-native token already deployed, and we do already have a native token here. Next, we want to compute our token ID. Remember, I mentioned briefly before when I was talking about the salt here that ITS has these interchain token IDs, which it uses to track tokens across different chains. So I'm going to actually show you how ITS calculates that token ID. We don't in general need to do this. I will just need that token ID on the destination chain before we actually deploy it. So I'm going to compute it myself and send it over. The way we do this is kecac 256, and we want to encode another hash of the string ITS interchain token ID, and we're encoding it with the address of the deployer, which is this token factory, and a unique salt. This salt, you might recall, is the salt we passed in here in our initializer. And we are getting yelled at. Why are we getting yelled at? This should be a bytes 32. We're getting yelled at here as well. This should be token ID. Might have one too many brackets. Kecac, no. We did have the correct amount of brackets. We want to close it here. And close this here. There we go. So now we have our computed. This will be our token ID as ITS recognizes it. Any questions so far? No, we're good. Next, we want to set up our GMP message. What is a GMP message? Recall, I mentioned it briefly on the slide here. A GMP message stands for a general message, is, as the name suggests, a message which can be sent from chain A to chain B. It can be something as simple as hello world, or it can be something as more developed as what we're about to send here. GMP messages, it's called GMP payload. They have to come in as type bytes. We're going to actually send this computed token ID as part of our GMP message. So let's pass this in right here. We're also going to send the creation code of our semi-native token and the initializer semi-native token initialize.selector. I hope there's no typos here. And this will be our GMP payload. This is the message we're going to be sending from our factory on Silo to our deployer on Moonbeam or any other chain that we're going to be deploying on. So we're encoding the token ID, our ITS token ID, our creation code here of our semi-native token, and our selector of the initializer. Because we're basically going to be, once this function calls, we're going to, on the destination chain, all in one click, all by calling this function, send the cross-chain transaction and deploy the semi-native token on the destination chain. Easiest to visualize by here. We call this function, deploy remote semi-native token. We send a message to our deployer on Moonbeam, and then the deployer deploys the semi-native token. In order to do this, it needs to know, like, hey, what is my creation code? What is my initializer that we're going to be immediately calling? So that's why we're passing all this as a GMP message from here. Now we can come back to what I promised I would mention earlier, our gas service and our gateway. Two super important contracts which we're passing in right here with our initializer. When we're sending a GMP message, we have to do two things. The first is interact with our gas service. What does this do? It allows for us to basically pay for the entire cross-chain transaction and the token of the source chain. So in this case, we're sending a transaction from Silo via Axelar to Moonbeam. What does that mean? It means that there'll be a fee that needs to be paid on Axelar and on Moonbeam. And we can pay for all this in the token of the source chain, which is Silo. And that is what the gas service allows us to do. So it takes in several parameters, including like, hey, who's paying for this? That's this contract. What is the destination chain that the transaction will need gas for? What is the address on the destination chain that we're going for? To string. That will be the deployer. It'll be like this instance on Moonbeam. What is the GMP message that we're sending? Remember, it could be hello world GMP message, or it could be what we have on here on line 94. And the last parameter we need is who do we want to receive a refund in the event that we send, let's say we send like 10 CELO, just because we feel like it, and we obviously won't need 10 CELO, then who do we refund the difference? And that will be message sender. Next, after we paid the gas, we want to interact with the second contract that we passed in here, or the third, which is the gateway. Gateway will expose a function called call contract, which is the function that we'll actually use to, now that we paid for the transaction, trigger the cross-chain transaction. It needs to go similarly. Where is it going? Like what chain? What is the address of the destination chain that it's going to? And what is the message that is delivering on the destination chain? And that's it for this function. Once we call it, we will construct this GMP message, which consists of our token ID, our creation code for semi-native token, and our initializer selector. We will pay for the cross-chain transaction gas, and we will actually trigger this transaction. So at this point, once we call this, we send off our transaction from CELO. It goes to Axelar, and then it goes to Moonbeam. But we get to Moonbeam and flop because it doesn't know what to do once it arrives at Moonbeam. So this is the second half of sending a GMP transaction. We're going to actually have to trigger this execute function. The execute function will be triggered by an Axelar relayer automatically, and it will basically execute whatever logic we want to run once the transaction is called. And there are a bunch of parameters here that we get for free. I have this written in line 55, validate contract call. This will basically make sure that the GMP message or the payload that is being received here is actually an authentic one that has been confirmed by the Axelar network itself, and not some like bogus, potentially malicious message where that's being used to mess up the state of your contract. So it's very, very important that we make sure that nothing executes unless this validate contract call gives us the thumbs up first. Now we can actually start to write up some of the functionality that we want to execute once this deploy remote semi-native has gone from CELO to Axelar. We've arrived on Moonbeam now. What do we want to do? Well, first things first, remember our GMP message, we've encoded it into this not very useful bytes object. So let's decode it into the actual useful data points that we passed in. So remember, the first thing we passed in was the, if I could type, was the computed token ID. Remember, right up here on line 92. So let's get our bytes 32 back. Next, we want to get our semi-native token bytecode, which we passed in, and then our semi-native token selector. We get all this by calling ABI decode on the payload. Payload is this parameter here that we got for free. It represents our GMP message, and we want to decode it to type bytes 32, bytes, and bytes 4, exactly what we passed in here on the left-hand side. Great, so now we have our GMP message on the destination chain. Now we can actually do some stuff with it. Well, what do we want to do? We want to do something similar to what we did in this function here. Recall this function here, what we did? We deployed our implementation, we deployed our proxy, and we hooked it up to IPS. That's basically exactly what we want to do here now, except now we're not on CELO, we're on whatever the destination chain is. So let's do this. We want to deploy a new token implementation. I'll use create3 again. We're already inheriting from create3 up top. We're going to pass in the semi-native token bytecode, which we received here from our GMP message. Remember, it's what we passed in up here, wherever the GMP message is, over here. Where was I? New token implementation. And then we want to pass in a salt. Remember, create3 needs, in addition to the bytecode, it's going to need a salt to actually make sure that the address which it's creating is what we want it to be. So I'm going to pass in, what was our salt implementation? I'm just going to pass in the raw hex here. So now this implementation will match up to the exact implementation address that we had on the source chain. And then let's do our check. If native token implementation is address 0, then hey, something went wrong and immediately revert with deployment failed. Any questions? No, we're good. Now that we've deployed our implementation, let's set up our proxy deployment. Remember, upgradable contracts, the proxy talks to the implementation. The proxy is the more important one per se. That's the address which your users will actually be interacting with. So we have to generate this creation code for the proxy. And just like in the previous function, we have our get encoded creation code semi-native, just like how we had it here. It'll be doing something very similar. It's going to need a few addresses. Here's the address right here. It's going to need our proxy admin. In other words, the address which can actually upgrade the contract. That'll just be the deployer address, so address this. It'll need the new token implementation, which the proxy will be pointing to. It'll need our computed token ID. Remember, that's what we passed in at the beginning. And it will need the selector, which will be called as soon as the token proxy gets deployed. So now we have our creation code proxy. I'm not going to go through this function. It's very similar to what we had on the previous contract. Now that we have our creation code, we can actually deploy this proxy. How are we going to do it? Take a guess. It's going to be, once again, create 3. Why? Because we want the token proxy to be the same address as the proxy on the source chain. So we pass in the creation code proxy, which we just created up here, and salt. And let's make sure we're matching the salt proxy 1, 2, 3, so that we have the same address. Now that we've deployed it, let's make sure it went okay. Let's check if we're in address 0. If we are, then hey, your deployment failed. Abort immediately, or revert, I should say, immediately. Awesome. And now let's store this proxy in storage instead of in this variable here, because we'll need to use it later. So let's store it as a type I transparent upgradable proxy. This is an Open Zeppelin transparent upgradable proxy, which we are importing somewhere here. If someone can see it. Yeah, right up there. Okay, so let's store it of type transparent upgradable proxy, and the proxy is this new token proxy. Cool. And now, once this function gets executed, we will have successfully deployed a proxy of a semi-native token on Moonbeam. Remember, all this execute stuff is happening on the destination chain as triggered by this call contract function on line 104. Sweet. But there's one more thing we have to do. Remember, deploying the token is not enough. We also have to wire it up to ITS. Otherwise, we won't be able to actually bridge these tokens between Moonbeam and Silo. So we do it the exact same way we did here. We have to call, where is it? Deploy token manager. In fact, I'm literally just going to copy it and throw it right here. We don't actually need a variable here this time around. The salt is the same. It's just the ITS token salt. It's still going to be, let me actually pull this up so you guys can recall how this is done. It's still going to be an empty destination chain because we're deploying it from the destination chain itself. We're not sending a cross-chain call here. The token manager type is going to be different. This time it's going to be mint burn because we're not on the home chain anymore. The params should be the same. The operator is just the deployer, and the token that we're connecting is this new token proxy. And let's actually just set it to 0 this time. We don't actually need a message value. And that is it. Now, once we have deployed this contract after deploying the proxy, and we have now connected it to ITS, there's one, I promise, final thing we have to do now is let's send one more cross-chain GMP message back to Silo now. So this is going to be a two-way call. We're calling this deploy remote semi-native. We send a cross-chain call with call contract. We hit execute on the destination chain. We go through all this logic of deploying the token, wiring it up to ITS, and now we're going to send a call back to Silo. And you might be saying, Ben, like, why are we sending this new call back and it's going to be going back to the source chain, to the source address. Well, that is because we want to actually track the address of this newly deployed token in this mapping, which we had up here, the semi-native tokens. We want to know that, hey, on Moonbeam, we have this address. On Ethereum, we have this address. So we can track from our home chain where all our semi-native tokens are deployed to. So we send the transaction back by calling call contract. It's very important that we do it in the execute function. So this all goes automatically. Remember, the Axelar relay will be triggering this. So we pass in the source chain. We're going to the source address on the source chain. And then what is the message that we're sending? It will be this token proxy address. I'm going to call from memory here so we don't have to do an expensive storage read. And then remember, GMP message means we have to encode it to type bytes. You might notice, if you're really cute about this, that we're not calling pay native gas for contract call the way we did on our original transaction. We're just calling call contract. That's because this is a callback. We don't have to double pay gas. We'll be using the gas from this original call that we made. The Axelar system is smart enough to pick that up. And that is it. Now, once we deploy this, we will be sending this transaction back to Token Factory. But on Token Factory, it's going to have to be able to handle this incoming cross-chain call the same way we handled it in the execute function. Here, we have to handle the cross-chain call and the execute function back on our source chain now. Now, this execute function is going to be way more straightforward than the one we just did. All what we have to do is, well, first and foremost, source chain source address, call this super important function. Remember, validate contract call to make sure that the data that's being passed in is authentic. So I just copied and pasted this from our previous function. And then once we have that, we can take our semi-native tokens mapping, which I just showed you up top, and then map which chain is this token deployed on. It's going to be deployed on the source chain of this call, so Moonbeam. And then we just decode our encoded function, our encoded data type, our encoded payload here, and it's going to be of type address. Remember, all what we're passing in is this new token proxy. This is the message that we're sending back. We're sending back the address of the token that we just deployed here so that we can decode it to get it back to type address and then map it and all future token deployments right here in this mapping. And we are basically done. We can basically go ahead and test this. See if there's any questions that have come in. I don't think so. The one final function which we want to do is, remember, this is an upgradable token. I hope I didn't miss any other functions. I think that is it. But let's just have a quick helper function to actually upgrade this, this token here. So let's write that up very quickly. It's going to need a new implementation. First, let's have the token that we're actually upgrading. So in practice, we'd probably upgrade this semi-native token. I guess I should have shown this before. This is the semi-native token, which the deployer is going to be deploying. Note that it's different than the native token. For context, native token, semi-native token. Semi-native token is the simple version of the native token without all the features of the native token. This is a quick refresher. So that is this guy right here. You can see all it has is mint, burn, interchain transfer. That's really it. So let's just upgrade this guy to a newer version. In practice, we'd want to probably be upgrading semi-native token to a native token. So that could be a kind of tricky upgrade. So let's just upgrade to semi-native token v2 for now, just for the purpose of this demo. And I'll write a blog about this too, where we'll actually upgrade to the proper native token instead. So this should be semi-native token v2. And let's just have a random function here just to confirm that the upgrade has gone to. Public is v2. Public pure returns bool return true. So once we upgrade, we'll call this as v2, and we can confirm like, hey, did the upgrade go through all right? How do we actually upgrade though? Well, we have this function signature. Let's write this guy out. So first thing we want to do is call, well, actually the first thing we want to do is import semi-native token v2. We then want to deploy a new implementation, just the way we did here. Because remember, proxy points to the new implementation. How do we upgrade the proxy? We tell it, hey, proxy, point to this new implementation. And this new implementation is not going to be semi-native token bytecode. It's going to be semi-native token v2. In other words, what we just defined 5 seconds ago. And we're going to have, doesn't really matter what the implementation, I'm just going to put a 5, random new implementation address. Same if statement, make sure that we have an address. If our address is address 0, something's gone wrong. And now let's actually do the upgrade itself. We call proxy admin, which we are passing in on line 88. We call our lovely upgrade and call function on our proxy admin. We are upgrading the proxy, which recall we have in storage here. We are upgrading it to this new implementation here of semi-native token v2, which we just deployed. We can leave this last parameter empty, I believe, for now. And that is it. That is straightforward as upgrading the token. Oftentimes you see upgradable tokens like going through like hard hat plugins. It's kind of nice to, it's kind of interesting to do it by hand, I should say. It really forces you to understand exactly how it's working under the hood. And that is it. I probably should have done this a while ago. But let's actually compile this contract, because that was a lot of code we just wrote. I'm sure I did something wrong. If not, oh wow, first for everything, I guess. How are we for time? We're right at time now. I'm gonna keep going here to actually test out this contract on testnet. So we'll actually deploy the factory, and then deploy the token via the factory, bridge the token from CeeLo to Moonbeam, confirm that it worked, and then try upgrade the semi-native token on Moonbeam. That's what we're gonna try to do here very quickly, and then we'll call it a day. So let's deploy this oh, it's something wrong here. Unpredictable gas. Oh, I think I know what this is. I already wrote a deploy script. Pardon me, it's very ugly. I hope this is the issue. We're using create threes to also deploy these what's it called? Sorry, that was a test. The token factories themselves. I have a very ugly deployment right now. I wasn't proud to show it off, but we just need to make sure that the salt address that we're passing in here has not been used already. I think that is the issue. In practice, you'd want to have a way prettier deployment script. File. Hopefully that was the issue. Let's see. Okay, it seems to be going now. Any questions so far? Yeah, the deployment script is basically doing exactly what we just did in the factory, but just in way uglier JavaScript. And I was just kind of manually updating the salt across both chains to make sure that our addresses are the same there. So you'll notice first we're deploying on Moonbase. We're deploying the deployer contract here, as well as the access control for the deployer contract. And then once we have the deployer contract, we can deploy our token factory contract on our home chain, on CeeLo. And we'll actually be passing in that deployer address, which we're deploying right now, onto CeeLo. And then we can, that's why we have to deploy Moonbase first. And then we can actually start to interact with these tokens. I'm not sure why it's taking so long. Hopefully this doesn't error out for us. It's happened to me in the past. But once this goes through, we can then deploy the token factory here on CeeLo. Sweet, we've deployed the access control and the deployer. Now let's deploy onto Moonbase. Notice it takes a parameter. The parameter is this deployer contract, which we just deployed. So let's pass that right in. Hopefully CeeLo should be a bit faster than Moonbase was. Let's give it a second here. And once we're deployed here, the first function we're going to want to call is the function that was already built for us, deploy home native. What will that do? It will deploy our native token. Remember the very first thing we built together. It will deploy this contract onto CeeLo. So we got it. I'm going to go through the hard hat console here just for simplicity's sake. So we will have token factory on this contract. Let's attach this address here. I hope you can all see this. Please, someone comment if this is too small. Make it here so it's a bit cleaner. And now, what do we want to call? We want to call deploy home native. I've already called it before, but what it's going to take in is the burn rate. Remember, 18 decimal points here. So I believe this equates to like 1%. And transaction fee rate, this should equate to like 3%. And let's call this. Now, I love CeeLo. Some people might be asking, why CeeLo and Moonbeam? Working faucets, fast finality time. I love working on these two chains. Great. So this went through. We should now have, remember at the bottom of this function, one of the last things we did was in storage, store the address of our token proxy. Native token should now return an address. It does. And let me pop this open here. So now that we have our address, our token deployed, let's actually interact with it. So native token v1. Let me pop open this contract here so we can take a look. Remember, this is the contract with minting, burning, with the transaction fee rate, with the burn rate, claiming rewards. I'm not going to go through all the claim rewards testing right now. We're already over time. But let's actually mint some tokens here and then send it cross-chain. So we want to pass in this address here. Let's mint to my address. And let's confirm that I minted correctly. Oh, did not mint. What did I do wrong here? Native token v1. Oh, sorry. CeeLo is not that fast, I guess. But you can see here we do have the tokens minted to our address now. Now we can actually send this token cross-chain. But there's a few things we have to do before we can send this token from our address here on CeeLo to Moonbeam. First, we actually have to deploy remote semi-native token. Otherwise, the token won't exist on Moonbeam, and there'll be it won't be wired up to ITS. Remember, that's what this function that we wrote up together did. So let's call this function because this will take some time to run. Deploy remote native semi-token. We're going to deploy it on Moonbeam. This is our only parameter that we expect. And since we're making a GMP transaction here, we have to pass in some native tokens to actually cover the transaction cost. So we're passing in message value here. So hopefully this works. It did. Apologies for the error we had and any future errors. Live coding, Murphy's Law, we know how it is. Anyway, this transaction has now been sent. But before we can also send this, we have to do one more thing. Recall that we have a lock-unlock type token manager here. And if we dig through the ITS contract, you'll see that it eventually is calling transfer from, which means that we have to approve ITS to actually transfer on our behalf, or we'll get an ugly revert message. Cool. So now we're good to go on our source chain. But we're still waiting for this call contract, for the message to go right now from CeeLo via Axelar to Moonbase. So let's track this. I can see the transaction hash. And let me exit our slides here. And if I go to AlphaJories, if I pronounce it right, I can throw in this transaction hash, and I can see that this went through. But this is not really relevant for us because we need the transaction to go through Axelar and onto Moonbase. So now is a good time to showcase the Axelar scan testnet explorer. It's pretty awesome. We can see all these, once it loads, you can see all these cool stats about Axelar, though these are all taken with a grain of salt. This is testnet, not mainnet. So I'm going to throw in this exact same transaction hash that we had on the CeeLo scan, and we should see the step-by-step of the transaction actually being executed. It might be done already. And unlike on a CeeLo scan, we could just see the CeeLo transaction, we can actually see the transaction going from CeeLo to Moonbase. Moonbase is the testnet of Moonbeam. We can actually see all the step-by-step of it going through. We can even click on the little CeeLo icon, and it takes me back to the native CeeLo Explorer. Same thing here. This takes me to the native Axelar transaction on the Axelar Scan Explorer, where I can really see the step-by-step of this transaction going through. It should wrap up any second here. In the meantime, I already showed this, right? ITS front-end portal. Yes, I did. But this is the no-code solution for deploying your token. Just wanted to show that off for a second. Cool, we're on the approved step. This basically means, you see this transaction actually took place on Moonbase. This is basically saying like, hey, Axelar's validators have now come to consensus about this transaction that was sent from Silo. We're good to go. We're letting our gateway contract, which is an Axelar contract on Moonbase, know that like this transaction has successfully gone through. And now the final step is the actual execution of this transaction. But remember the way we built this, there's one more thing that's going to happen as well. Once this execute function, which is on our deployer contract, which will be A, deploying the implementation, B, deploying the proxy, and C, connecting it to the ITS token manager here, it will actually be sending a callback transaction back to Silo. Remember, it's kind of a ping pong transaction. Obviously, it doesn't have to be like this every time. I just kind of wanted to showcase this feature. So you can see it now executed on the destination chain, and at the same time, without me pressing a button, it's sending back to Silo with this very simple message here. So we don't have to wait for it to go all the way back. We can actually send the interchain transfer already. So if I click on this executed transaction, I can see it on Moonbase. So congrats, we've just made a cross-chain transaction. First of several we'll be doing here. And I can see all these amazing logs of deploying the upgradable token, connecting it to ITS. And what we can see here, the most important parameter I want for us right now is the interchain token ID. This is the token ID which ITS will be using to track this token on Moonbase, on Silo, and on any future chains which we'll want to connect this token to. Okay, so if I go back to Silo now, remember what we want to do. We want to send our tokens here, which we have minted. We minted back here. Remember, we minted the token, and we have a balance of 2 to the power of 18 here. And we want to send those tokens now from Silo to our newly deployed ITS token on Moonbase. There's tons of ways to do this. We can do it right from the token itself. I'm going to do it through the ITS contract itself, 0xB5. This is not our contract. This is ITS, what's kind of powering all this under the hood. But I could, if I wanted to, program in some interchain transfer function into our native token contract itself. But for now, I'm just going to go through ITS. So let's first of all confirm our token's address. How am I doing this? Remember, I grabbed the interchain token ID from Moonbase, and I'm going to throw it into ITS. And if all goes well, this address should be the same address of the token that we're about to send, which it is. You see, this is the one we wired up here. 0x718 is exactly what it's returning right here. So now that we confirmed that this token ID is wiring up to our correct token, we can actually send this token. So let's do it. Let's pass in our new token ID. We're going to be going to Moonbeam, destination address. This is just going to be like my personal EOA I'm going to be sending it to. Let's send like 1, 2, 3, 4, 5 tokens. We have no metadata that we're sending in here. And the gas value has to correspond to the Ether, the payable amount that we're using to pay for this transaction. So hopefully, let's see if this works without any scary revert message. All right, that's a good start. No revert. And now we can view our transaction. Again, we could view it here, or we could go to our nice fancy Axelar Scan Explorer. You can see some of the tokens here being burnt as we programmed it to do in our update function, which is pretty neat that the burn functionality is working correctly. But more importantly for us, let's see if this token transfers. In the meantime, let's get set up here. I'm going to point this interface here to Moonbase. We're going to call semi-native token, because that is the token we have on Moonbase. Having said that, it will still be the same address as our address on Silo. Remember, the address on Silo for our token, as it told us, was 0x718. And I'm going to paste in the silo address here to Moonbeam. And if all goes well, we should be able to interact with the token at the exact same address. Nice. So you see this is the same address on Moonbeam as it is on Silo, and I can call name and it gives me semi-native token. So we have successfully deployed, now we have confirmation that we've successfully deployed our token onto Moonbeam. And now let's see if this interchain transfer has finished. It is still going here. You can see if I go back, yeah, you can see our two-way call has finished executing. So pretty nice to see that that guy worked. And hopefully momentarily, we should see our, notice this is interchain transfer, different than call contract, the one we had here when we were just sending the kind of plain GMP message. AccessScan can pick up a unique interchain transfer. Sometimes AccessScan can index it behind. Let's see if it's there. Okay, still 0, so the tokens have not arrived yet. It's approved. Should execute momentarily, and then when it does, hopefully we should see the balance of our token on Moonbeam, or Moonbase, I should say, incrementing to 1, 2, 3, 4, 5, which is, if you recall, the amount that we sent here for our interchain transfer. Let's see, did it go? 1, 2, 3, 4, 5. Nice. We have successfully sent tokens from Silo to Moonbase and burnt a few in the process, if you recall, seeing that on Silo Scan. So that's it. Basically, everything works here. One more thing we can test. I know we're over time, but we're here. Let's test it. Should be quick. Is the last function that we implemented, the upgradability. Like, can we actually upgrade this token? So let's do that quickly. I'm gonna let's do this. Actually, yeah, exit. Clear this. Oh, whoops! I accidentally deleted the address of the deployer. That wasn't very smart of me. Should be fine. Cost of deployer. We just need to get the address of this deployer now, which can track here. I think it should be this guy. Let's see if this is our address. Await contract SITS. Let's just call it generic. Yeah. So we know this is the address of the deployer because we just called the generic kind of public getter, which is the variable SITS. And it's working, so we know we have the correct address of the deployer. Now let's call upgrade semi-native token. We've been pretty smooth on things working despite live coding. Hopefully this works too. We need to pass in the address of the proxy admin, which I believe we can just see here in the event logs. We can also let's see, I think it's this guy. Yeah, proxy admin, you can see it being called out here. That is the proxy admin of our token. And that should be all we need to pass. So what's gonna happen now is let's just call it. Yeah, what's happening now is we're deploying a new implementation of semi-native token v2. And we are calling upgrade and call from our proxy admin to point our proxy to this new implementation. And how will we know if it worked? Well, remember, semi-native token is the exact same, semi-native token v2, that is the exact same as semi-native token v1, except for v2 has this new public is v2 function. So let's check if this works. We're going to go back to our CLI on the bottom this time. Sorry for hopping around. We're going to call semi-native token v2, and we're going to pass in the exact same address. Like, it's still the same proxy that we're dealing with. And hopefully if I call is v2, we'll have had a smooth demo, which we did. Nice. We can now see that we can call is v2 from the exact same proxy address, which means our upgradable function worked correctly. And that was a lot to take in. So any questions, I am happy to answer, be it now or after the fact. Happy to connect here, Discord, Twitter, wherever. But that is our working demo. One more time, we have our token factory and our deployer, which are kind of instances of each other on our home chain and on our satellite chain. They're both governed by access controls. Token Factory deploys this native token v1, which has our custom functionality of obviously mint burn, but also like the burning of the tokens to combat inflation, and the calculate and the reward pool for token holders. Semi-native tokens are the more vanilla, just mint burn, interchain transfer. Having said that, even though they're different, we can still send tokens between the two different chains. And then we can update the semi-native token in theory to be a native a native token someday. They're upgradable. They're deployed via create 3, so they have the same address across all these different chains, and they have some advanced functionality to them. And that is it from me. Thank you very much for listening. Again, my name is Ben Weinberg with the Interop Labs team. Happy to help in any way I can, and thank you everyone for joining. Cheers, have a good day.